Okay, the back side of lesson 3.3 talks about binomial expansion. I told you if you worked on homework last night, anything that said binomial expansion or Pascal's triangle or expand, I said my recommendation would be to skip those right now, and I'll go through them with you today. So the idea, so jump down real quick, look at example A. X plus y to the sixth. We've got a couple of different ways we can do x plus y to the sixth. One way would just be to do a lot of FOILing, yes? I mean, writing out x plus y, x plus y, x plus y 6 times and FOILing it out. That is a legitimate option. And if you want to take that route, so be it. I'm going to teach a shortcut. Now, the shortcut's not quick, but in my opinion, it's definitely better than having to multiply out x plus y 6 times. Okay? So, this is called binomial expansion, okay? Because we're taking a binomial here, and we're expanding it. So, it only works if it's a binomial, so where there's 2 terms. So, of the form a plus b raised to the n power. Your expansion, so like when we get this done, is going to contain n plus 1 terms. What that's saying here is when I do example A, this exponent is 6, right? Mm-hmm. So that means my final answer is going to have 6 plus 1 terms. Or in other words, my final answer is going to have 7 terms. Which is why, as I flashed my completed notes, it's long, isn't it? Yep. Because there's 7 terms there. Okay. Point 2. The coefficients of each terms are numbers from the nth row of Pascal's triangle. And so we're going to talk about Pascal's triangle and how that can help us here. Okay. The idea of Pascal's triangle, it's a pattern of numbers. The top row is row 0, and that's just a 1. Okay. From that, what happens is each number in the rows below it is the sum of the 2 numbers diagonally above it. So, for instance, easiest way to look at it, so row 1 is just, this diagonal number has a 1 above it and nothing, so 1 plus 0 is 1. Same thing over here. We get down to row 2. Okay, this middle diagonal number, this 2 comes from 1 plus 1 is 2. The 1's just carry down. We get to row 3. Your outside 1s are always carrying down, and then 1 plus 2 is 3. 2 plus 1 is 3. That 1 carries down. Row 4. Are you seeing how the pattern works here?
Yeah.
Carry the 1s down. Where does this 4 come from? 1 plus 3. 3 plus 3 is the middle 6. 3 plus 1 is 4. Carry the 1 down. Does Pascal's triangle stop at row 4?
Oh.
No. I screenshotted one that has up through row 7 down here, example 1. And I think up through row 7, it'll get all of our examples here. Does it get all the examples in homework? I think so, but I don't always see all the different exponents they're going to give you. Okay, but I tried to give you, this is an example of Pascal's triangle that if you keep expanding it. Can you extend it more on your own? Yeah. Could you Google Pascal's triangle and maybe find one expanded more on your own? Very possible. Okay? So that's the idea of Pascal's triangle. And we're going to use that because that's going to help provide coefficients here. Okay? And I'll explain that in a moment. Okay? Point 3, the exponent of a is n in the first term and decreases by 1. So we're going to start, when we go through here, we'll start high, decrease. The exponent of b is 0 and increases by 1. I'll explain those when we go through. And the sum of any exponents is always going to equal whatever our exponent was to begin with. Okay? Those will make sense as I explain example A. Okay? So let's give it a start. Example A is x plus y to the 6th. Because it is power of 6, what row am I going to use in Pascal's triangle?
Row 6.
Row 6. Genius, right? Okay, so we're going to use row 6. The first thing I'm going to do is I'm going to write out the numbers in row 6. And I'm going to space them out pretty much all the way across my page so I have room to fill in my missing pieces. So row 6 is 1, 6, 15, 20, 15, 6, 1. I'm going to try and space those out. Try here being the key phrase. There's my 1. I'm going to leave a little bit of space. There's my 6. 15. 20. 15. 6. 1. And what I'm doing is I'm leaving space so I can fill my other, because there's going to be 2 pieces we have to fill in between each of those. Now, as you get better about this, maybe you'll just write it as you go and you won't have to write it out and leave your gaps. But this is the easiest way for me to teach it. Okay, so that's kind of point 2 there. And if you notice, we're in row 6, but how many numbers are there here? There's 7. Representing that we're going to have 6 plus 1, or in other words, there's going to be 7 terms. Okay? Okay. I'm going to change colors here.
Right, orange.
Now, so point 2, or excuse me, it's point 3 up there. The exponent of A is the n in the first term and decreases by 1 in each successive term. So in my A spot is right here is the x, right? If we think about this as A plus B to the nth. So we're going to take the first piece, the first term in my binomial, and we're going to start and we're going to put it in each place. My high power here in this problem is 6. So next to the 1, I'm going to have x to the 6th. Next, in the second gap, so next to 6, I'm going to have x to the 5th. We're decreasing. After 15, I'm going to have x to the 4th. X to the 3rd. X to the 2nd. X to the 1st. And what should you be ending on?
X
to the 0. We'll talk about what x to the 0 here is in a moment. Okay? So that is point 3. You start with the first piece, decrease your exponents. Now, point 4. Now we're going to take the other one, which is the B term, which in this case, B is y for me. And now, instead of decreasing, we're going to increase. So this time, we're going to start at 0, and we're going to increase and end up with y to the 6th at the end. Okay, so this is why I left the gap. So we have 1 x to the 6th, y to the 0. 6 x to the 5th, y to the 1st. 15 x to the 4th, y to the 2nd. Y to the 3rd, y to the 4th, y to the 5th, and I end up with 1 x to the 0, y to the 6th. You there?
Yeah.
Okay. Now, in between each of my 7 terms are addition signs. So I didn't put them in there, but I'm going to throw in, it's going to be plus the 6, plus the 15, plus the 20, plus the 15, plus the 6, plus the 1. At this point, it's just cleanup. On some of these problems, there's a lot of cleanup. On some of the problems like this one, there's really not a lot of cleanup. It's very minimal cleanup. So, 1 x to the 6th, y to the 0. Well, first of all, the coefficient of 1, we don't have to write. X to the 6th is x to the 6th. What is y to the 0? Anything raised to the power of 0 is always 1. Which, if that's 1, what is 1 times x to the 6th times 1? X to the 6th. Okay? Plus, what's 6 x to the 5th times y to the 1st? Well, 6 x to the 5th, and I'm just going to write y. I don't need to write y to the 1st. Plus 15 x to the 4th, y to the 2nd is just 15 x to the 4th, y to the 2nd. 20x to the third, y to the third. Just continues. Plus 20x to the third, y to the third. Plus 15x squared, y to the fourth. Just stays. Plus 6x to the first, y to the fifth. I can write as 6x y to the fifth. I just don't need the x to the first.
Yeah.
Plus, what about this last term?
Y to the sixth.
Okay. 1 is 1. X to the 0 is 1. And so 1 times y to the sixth is just y to the sixth. Now, if you don't like what I just did, then your other option is to FOIL this all out, which would be x plus y 6 times, FOILing it out. I personally will pass on that. That's your answer. Okay. There's some other tricks when things get a little more challenging, but that's the basics. I just showed you a basic one to start off with a plus sign in the middle and an x and a y, no extra numbers or anything. Now, some things to notice. We were in row 6. We had a power of 6. We ended up with 7 terms. So it's always one more than that number of terms. And then another thing to notice, as you look at each term, the sum of the exponents in any term is in. It's x to the sixth. Here it's x to the fifth, y to the first. 5 plus 1 is 6. Exponents, 4 and 2 is 6. 3 and 3 is 6. 2 and 4 is 6. 1 and 5 is 6. And 6 is 6. So every time, all of those terms, my exponents always add to be 6, whatever power we were working with here. Okay, questions? Okay, let's try example B then. Now, I'm going to say example B gets a little trickier. Even though it's smaller, we're throwing in a number in there instead of just variables. But we're still going to think about it the same way. So, what row are we talking about here? Okay, we're going to be using row 4. So my recommendation is you go find row 4 on one of the triangles, and you write it out, and you kind of space it out so you have room to fill stuff in, right? One, 4, 6, 4, 1. Aaron, I have a Band-Aid if you need a Band-Aid.
All right.
If you decide you do.
I popped a nerve yesterday, so it was like bleeding on my skin.
Okay. Now, we're using 1, 4, 6, 4, 1. You remember what to do next? Okay. So we're going to take, yep. Okay. Take the first thing in the parentheses. In this case, it's x. We're going to start with the highest power, so x to the fourth. And we're going to work our way down. Where should we end up at? X to the 0. So x to the fourth, x to the third, x to the second, x to the first, x to the 0. Now, the other part is B. What is my B term here? B is negative 3. Did you catch that? We have to take the negative with it, which adds a little level of complexity, right? So we're going to do B as negative 3. So I'm going to put this in parentheses. We start with negative 3 to the what power?
0.
0. So the second piece, we're starting low, and we're increasing. So negative 3 to the 0. Negative 3 to the first. Negative 3 to the second. negative 3 to the third, and negative 3 to the fourth. In this example, my exponents are always adding to be 4, yes? Granted, some of those exponents are going to go away. By default, there are plus signs in between each term. Okay. So, it's a matter of cleaning it up here. On the first term, 1 is 1, x to the fourth is x to the fourth. What is negative 3 raised to the 0? Just 1, right? Anything raised to 0 is 1. So this first term is just going to be x to the fourth. Now, this next term, there's 4, x to the third. What is negative 3 to the first? That's negative 3, right? So when we do this, 4x to the third times negative 3. What is 4x to the third times negative 3 going to be?
Negative 12x to the third.
So I'm actually going to put another line down here. This is going to be negative 12x to the third. So my first term was x to the fourth. Now I'm going to have negative 12x to the third, or minus 12x to the third. Next term, I've got 6x squared times, what is negative 3 to the second? 9. Negative 3 times negative 3 is going to be positive 9. So 6x squared times 9 is going to become 54x squared. Next one, I have 4x to the first times, what is negative 3 to the third? Yeah, negative 3 times 3 is 9, times negative 3 is negative 27. And then we're at 4x times negative 27, which is
A lot.
Is that right? Yeah, minus 108x. And then the last one. 1 is 1, x to 0 is 1, times, what's negative 3 to the fourth? And this is where my brain says 3 times 3 is 9. Another 3 times 3 is, no, I go 3 times 3 is 9. And then I say 9 times 9 is 81. Or, Landon, you would have been going 27 times 3 and you would have gotten there. But my brain can easier do 9 times 9 in my head than 3 times 27. So, okay, 1 times 81, this is going to be positive. So plus 81.
Easy.
Okay. So you have to watch out for the signs, the numbers.
All of it.
Yeah. It's still better than multiplying that out 4 times, though. My opinion. Okay. One more. Two C plus D raised to the power of 5.
Row 5. Get that row 5 in there.
Okay.
Row 5.
We are going to be talking about row 5, which how many terms does that mean I'm going to have?
6.
6. Okay, what are my row 5 coefficients?
1,
1, 5, 10, 10, 5, 1. And maybe I overkilled a little bit spacing it out so much, but I have room. Okay, the first thing we're going to do, our A value, which is
2C.
2C. You have to take the whole thing. And we're going to start by raising 2C to what power? So it's going to be 2C to the 5th. And then the next term, it's going to be 2C raised to the 4th. 2c to the third. You'll notice I'm putting these 2c's in parentheses. Okay. 2c to the second, 2c to the first, and 2c to the 0. So we started at 5 and decreased down to 0. And now, my b value, which in this case is d. What do we start with d?
0.
D to the 0 and go up. D to the 0, D to the first, D to the second, D to the third, D to the fourth, and D to the fifth. By default, there are plus signs in between each term. Maybe you just want to wait and put them in on your final answer. Grabbing the calculator, huh? Okay, so first one's not bad. We have a 1. What do we know about d to the 0? It's a 1. What about 2c to the 5th? 2 times 2 times 2 times 2 times 2.
Wait, so 2 times 2 is 4. Times 2 is 8.
16. 32.
32.
Okay, so this 2c to the 5th becomes 32c to the 5th. Times the 1, that's just going to, it's just going to be 32c to the 5th in our final answer. Okay, next term. 5 is 5.
5.
What about 2c to the 4th?
16.
Okay, so we're going to have 5 times 16c to the 4th times d.
That would get you 80.
5 times 16 is 80. So this is going to be plus 80 c to the 4th d. Okay, next term. I've got a 10.
D.
What's 2c to the 3rd?
2c to the 3rd, 8.
So 8c to the 3rd times d to the 2nd.
Okay, it's going to be 80. C to the 3rd, D to the 2.
Okay, 10 times 8 is 80.
D to the 2.
80, c to the 3rd, d to the 2nd. Next one, I've got 10. What's 2c to the 2nd going to be? Four c to the 2nd. So 10 times 4c to the 2nd times d to the 3rd. 40c to the 2nd, d to the 3rd.
I left it out.
Plus, okay, this next one isn't bad. You've got a 5, 2c to the 1st, and a d to the 4th.
10C,
D4.
Okay. So you do end up with 10c d to the 4th plus
2C's Dawn. Well, it's
Okay.
just a 1.
anything raised to 0 is 1. So that 2c raised to 0 is 1
It's just D to the 5.
times d to the 5th, which is d to the 5th.
I know House money.
How many terms did I end up with here? 1, 2, 3, 4, 5, 6. And if you look, my exponents, because we had 2 variables in this one, my exponents every time add to be 5. It was c to the 5th, then it was c to the 4th, d to the 1st. And then a 3 and 2, a 2 and 3, 1 and 4, and 5. Every time, my exponents have that sum of 5. Okay, and that's because the exponent on the problem was 5. Okay, that did go pretty quick. It's kind of big, but once you get it, it's not horribly difficult if you follow the pieces. You just have to watch out, not make careless little mistakes, you know. Same as always. Okay. Lesson 3.3 in Savas.